All right, number 3. The graph of the continuous function g. The derivative of the function f is shown above. The function g is piecewise linear between -5 and 3, and g of x equals 2x minus 4 squared between 3 and x, or 3 and 6. If f of 1 equals 3, what is the value of f of -5? Okay, so like the first thing we kind of want to do, this is the graph of the derivative of f. So if we label it that way, that will kind of help us understand everything that we're doing. So if f of 1 equals 3, what's the value of f of -5? Okay, so for starters, I think this is the most elegant way to kind of do it, but it's not the only way to think about it. The integral from -5 to 1 of f prime of x, this is, right, I'm labeling it this way because that's g, right? Alright, and so this, by fundamental theorem, that'll be f of 1 minus f of -5. This is what we're given. This is what we know. Sorry, this is what we're trying to find out. And this is what we can find essentially from the graph. Or rather, this is what we can find from the graph. So let's find a couple of those things. Well, I mean, alright, so this is 3, right? Let's find the integral from -5 to 1. Okay, so here we've got -9. Here we've got -1.5. Here we've got 0. And here we've got 1. So that is -9.5. Solve this for f of -5. Add that, then we get f of -5. 12.5. Cool. Part B. Evaluate the integral between 1 and 6 of g of x dx. Alright. So, we want to find this integral. We're obviously going to break this up into 2 parts. We'll have the integral from 1 to 3, and we'll have the integral from 3 to 6. From 1 to 3, that's just going to be 4. And then from 3 to 6, we'll have to do some calculation using the function here. So, integral from 1 to 6 is 1 to 3 plus 3 to 6. This is 4 because it's a square, and this is the one where we'll have to do an antiderivative. 2x minus 4 squared. Alright, so what is that? Add 1, divide by that. We don't have to do anything with that because that's just going to be 1. 2/3 x minus 4 cubed between 3 and 6. So that is 4 plus 2/3 2 cubed minus 2/3 -1 cubed. And we end up with 4 plus 8/16 minus -2/3 18/3, so 6 and then 10. All right, between -5 and 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. All right, so increasing and concave up. We're looking for places where the derivative is positive. So that's this graph, essentially, right? Where this graph is positive, where g is positive, and where the second derivative is positive, right? So it's increasing where f prime is greater than 0. It's concave up where f double prime is greater than 0. So f prime is greater than 0 where g is greater than 0. That's all of this stuff. F prime will be greater than 0 where it's positive and increasing. So on those two intervals, between 0 and 1 and between 4 and 6. So increasing and concave up. Where the derivative is greater than 0 and the second derivative is greater than 0. And you're going to have to write something like that to show that that's what you're looking at. 0 to 1 and 4 to 6. D. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. All right. Points of inflection will be where the second derivative changes signs. So where the derivative switches from increasing to decreasing. There are two spots kind of like that. Right here and right there. Only one of those is a point. So only one of those actually is a point of inflection. So only one of them gets credit. D, where f prime changes signs. At x equals 4.